Okay, we have another more advanced problem from our section here on economics that you can do with calculus. And we're supposed to imagine that there's a plane manufacturer, and we're talking large, expensive jets, and it costs $500 million for them just to get their business set up. And then once their business is set up, this is the manufacturing cost, okay? So this is a new concept, manufacturing cost. But the first part here that says, well, what's the total cost function? If you think about it, all it's going to be is the cost to manufacture each plane plus those startup costs. So don't let them fool you. Just read through the problem, think it through, and you'll see that it's really just our cost function in disguise. So we can write C of x then, okay, is equal to that 500. Now they're telling you that this is in millions, so we don't need to add a lot of zeros. Just remember that all these numbers as they come out in cost value is in millions of dollars. So it's 500 million, then plus, that's 20 million for each plane, minus, and then on it goes, x to the 3/4. That's a bit random, but nevertheless, they've got some computer that's generated this based on statistics of their company or whatever. 0.01x squared. Okay, so that is the cost function. You're done with that part. You know that later on down the road we're going to want to take the derivative of that, okay? So why don't we just do that here to keep it sort of orderly. Then the marginal cost, or the derivative of our cost function, that goes away. We've got then 20, and then I use the power rule, so just be careful. Dust off those power rule skills. 3/4 times 5 will be minus 3.75. You can keep it as a fraction if you wanted. That would be 15 over 4. Then x, when I subtract 1 from 3/4, it goes to negative 1/4. Okay? Again, it seems a bit random, but this is correct. Plus, and then this is a little bit more normal with an integer there, 0.02x. Okay? So that's the marginal cost. The next thing they tell us is that we can find the price of our airplane based on how many we produce, okay? Now the problem is here they've also thrown a little bit of a wrinkle at us. They're not giving us the cost function. We have to work to find it. They're not just giving us that demand function. They're making us solve backwards. They've given us the price that will come out based on the production, but we want it the other way around. We want to know, based on the production, what price we can expect. So all we need to do is solve this. It helps to sort of take away the variable function notation and just say we're solving p that'll be in terms of x rather than x in terms of p. So how do I solve this? Well, I'm going to add the 7.7p to both sides. I'm going to take away the x from both sides. So this equation down here is just going to be 7.7p is going to be equal to 320 minus x when I move this over to this side and move this back to this side. But I need p alone, so, and I can write, well then p is going to be, now in terms of our variable x, so we can put it back into function notation like that. If I divide by 7.7, it's 320 over 7.7 minus, and then x over 7.7, okay, and that's our demand function. Well, if you like working with fractions, you're fine doing that. It's a little bit weird to have a fraction and a decimal, so I thought it would maybe make more sense to you if we just had it in terms of decimals. And so I've done that to save a little bit of time. Of course, I picked the wrong sheet of paper. But it is, this is 41.56. I chopped it a little tiny bit. And then minus, and this is 0.13x, okay? Well, that's our demand function. All we've done is we've solved this function for that. All right, so how do I get the revenue? Well, that's just a matter of multiplying by x. So the revenue function then becomes 41.56x minus 0.13x squared, okay? So again, we apply the concept of the derivative. We know that our profit is going to be the revenue minus the cost, the total money we take in minus the cost. When I take the derivative of that, I will then be able to set these marginal costs and revenue equations equal to each other and then solve for that. So the derivative of this, r prime of x, is 41.56 and then minus 0.26x, all right? So I've got the marginal revenue, I've got my marginal costs, and I set these equal to each other and solve. All right, well that's the trick. How do I solve something with this random negative 1/4 power? If you notice in the book, they've given us the nice little icon that shows the calculator graphing. So the hint there is just to graph this and then look at what happens when we graph them. When will these two intersect? When will they be equal to each other? If you wanted to write one long equation and have this minus this and set it equal to 0, you could certainly do that. But you'll see it's a little bit easier to type in the separate equations and see where they cross. Okay? So I've got that on the calculator here. Turn that on, and you can see, hopefully you can see that here in the top we've got 20 minus 3.75x, and then in parentheses to the minus 0.25, and then plus 0.02x, and I've got the second equation down below. We want to find out where these will intersect. Well, how do you know what the window should be? If you think about this, we got 41, so if x is 0, my y value will go up to 41. And if I sort of think about it like an intercept, it's going to be maybe, you know, a few hundred till I'll get my y to be 0. So I know that I'm only going to be in the first quadrant, so I can start at negative 10 just to see a little bit of the vertical axis, or 0, that's fine. I'm going to go up to 100. I'm going to have my scale be about 10% of that, and I'll do the same thing for the y. I could have been negative 10 there too. Go up to about 100 and hope that it shows up. So if I press graph, lo and behold, there's the descending revenue, marginal revenue, and here's the cost function. I just want to find where they intersect, so I can do second trace, choose option number 5, hit enter, 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 and it tells us that the intersection point is at 81.457. So just call it like 81.5, and that's going to be the number of airplanes I'll manufacture. This is not in millions because X is just in terms of airplanes, but they're asking what will be the maximum profit, or actually the book is only asking what is the production level. So I guess we have answered that. It's at these are equal when X is approximately equal to 81.5 airplanes, all right? If you want to know how much they should charge, well, then you can go up to this function right here. We could plug that in, and 41 minus 0.13 times 81 will tell us how much we should charge for each airplane. When you multiply these, it's very close to about 10, I think. So the price for the airplane should be approximately about 31 million, something like that. And if you wanted to find out what the actual profit the company would make, you'd have to just plug that 81.5 into your revenue, and then plug it into your cost, and then subtract those two, and you can see what your profit is. But there you go.